followers. So I put a lot of work into this program as the holidays are here. And this is my Python 3 running on Flask that controls the Pegasus. Anyway, I think I showed this part that adds the band you're working in. So I spent time today normalizing the sound so that when you touch these bands, the volume's the same and lower frequencies have higher volume, more static. Higher frequencies have less static, so I had to crank the volume up on these and crank it down on these. I also worked hard to make sure that the frequency here will auto normalize. So that took a lot of work. And what took a lot of work was getting the broadcast band to display the old fashioned kilohertz display. So let me show you that first. So broadcast band, there's 1000 kilohertz, the way it used to be. So now I can go through this. So that's a bit like the old days when you had a AM radio and the frequency was listed in whole numbers and integers. In this case, I think this is kilohertz. It is kilohertz actually. So I really wanted this to work. So the experience in using this radio is like using an old-time radio on AM. And also here I note it's AM broadcast band. Actually, that's an error. I'm still in broadcast here, so I gotta fix that. Broadcast happens until 1700, and then I switch off into shortwave listening mode. So now, if I hit 160, it pretty much tells me you're in 160 here. And if I hit, say, AM now, I use a greater step function for AM. So hitting AM, let's go to, there's 80 meters. It tells me where I'm at in 80 meters. Let's go to LSB mode. There we are. So I have CW now with a smaller step function. So if I go to CW now, I have more resolution, which is what you want in CW mode. And conversely, if I go to sideband again, it will increase the resolution. Or decrease it, so now I'm stepping faster. And if I go to AM mode, I step even faster. Because in AM, you don't need a high resolution. 3885. There's some guys talking. 3870. So this kind of gets it back to the old days, which I like. And now let's go to 40 meters. So this works nice now. Go like this. Can go to CW. Look around here. So I'm really happy with how this turned out. Go back to lower sideband here. And of course, you can choose AM, and it'll even go through faster with a low resolution. So I'm really happy now with how it's turned out. 30 meters on sideband. 20. And of course, you can go to AM mode and skip through faster with a lower resolution. And now I know when I'm out of the band, just look up here for the notice. There's CW, 17 meters. So I'm happy with how it's turned out. 15 meters. Go to AM mode. I still got a problem where I gotta fix the decimal points to make them even. When you go to AM from CW, you want to be on a 0. Anyway, there's 15 meters. Let's skip through an AM mode here. Go to AM. Don't hear much. Okay, 12 meters. Not much going on. And of course, 10 meters will be dead. Probably go to AM mode here. There's FM right there. And of course, I did put in 27 megacycles too, CB. So there's CB, and it's channelized. Okay, and I tried to get the volume consistent on all these bands. So if I hit broadcast, hit 160, I tried to make the volume consistent on all these buttons so that on the higher bands, the volume's higher and it sounds the same. So it's pretty consistent now. You can go through here and not be blown out of your chair with volume. On the higher bands, it raises the volume. Here's the WWV time sinks to see how the band's open or not. And because it's AM, it basically cuts the resolution down, which is fine. Notice how the volume is the same, pretty much. Nothing there, nothing there. CHU, CHU. Okay, so that's my demo. This has been a lot of work. I think I'm done with this for a while, but I'm happy with how it works, and I guess I can use it now and enjoy it. Okay, well, thanks for watching. Have a great Memorial Day. Barbecue, don't get burned. Make hamburgers, drink beer. Have a good life. Thanks for watching.